Okay, so what happens when a quadrilateral doesn't meet the properties of a parallelogram? When it doesn't meet the properties of a parallelogram, you either have an irregular quadrilateral, which could be a lot of things, or it could be a trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called the bases, and the non-parallel sides are called the legs. And what happens is you take a leg and a base, and you get a base angle. Now, obviously, there are four pairs of base angles, or two pairs of base angles. So here's a base angle, and here's a base angle, here's a base angle, and here's a base angle. We're going to find out that there's lots of different rules depending on what the kind of trapezoid you're talking about. But if the legs are congruent, then the trapezoid is called an isosceles trapezoid. An isosceles trapezoid has the most rules, but it's also the easiest to solve for stuff. So if you have an isosceles trapezoid, both pairs of base angles are congruent. So for example, if this is 60 degrees, then this is 60 degrees. You can also tell something about the other two base angles if you know these two. Obviously, this is an acute angle right here, and this is an obtuse. Based on what you know, how many degrees do you think this angle is? Well, it should be 120 and 120. Okay? And so that's how you know. And again, lots of things go into play here. Consecutive angles in a line should equal 180. Consecutive angles in a line should equal 180. These are congruent, but then also all four angles together should equal how much? 360. The other thing that's true about an isosceles trapezoid is that the diagonals are going to be congruent. And then the final thing that's true is the legs are going to be congruent. And so if we go to our workbook on page 167, one through 16, or one through, let's see, 1 through 10 is where we're going to focus right now. It says, find the value of the angles. Well, we just talked about 1 through 7 pretty good. And you should be able to do that, be able to name all four angles. And then in 8 through 10, it says find the value of the variables in each isosceles trapezoid. Well, again, we talked about that as well. If these two are congruent, you can solve for x. We know how much these two angles should be equal to each other, and then we know how to solve for those. So what I want you to do now is actually pause the video and go ahead and try to solve 1 through 10 based on the notes that we just took. We'll go ahead and do that, and you guys will be able to, we'll talk about them. Okay, so hopefully you're able to do this and solve for the missing values. Angle 1 was obviously 96, so angle 2 had to be 84 again because of the 180 rule. And I'm just going to let you look through 2 through 7. Obviously had to do with knowing what angles were congruent and then knowing what angles equaled 180 when added together. So 8 through 10, even simpler. You just had to set equal to each other what was equal for number 8 and number 10, and then you solve for the value of the variable. Number 9 was a little bit more difficult. You just had to add 6x plus 20 plus 4x, and that would help you solve for x. And then you had to use that to solve for y. And so 6x plus 20, when you solved that, you got 116, and then obviously y was congruent to that angle, so that's how you got 116. All right, let's go back through the notes. Obviously, the one thing you saw when you looked is an isosceles or a trapezoid period has a line that can go in the middle, and that line that's in the middle is called the median. And the median of the trapezoid is the segment that joins the midpoint of the legs. Now, in order for it to be a median, it has to be parallel to the bases, and it has a length that is equal to the mean of the bases. Now, I'm sure you're like, well, wait a minute, what does that mean? Well, it's as simple as this. If this is 6 and this is 12, then you add 6 plus 12 and divide it by 2. And so 18 divided by 2, this trapezoid has a median with length of 9. So in trapezoid ABCD, line segment EF is a median. Now notice we said EF is the midpoint, okay? And so we're gonna put a couple different numbers up here, just to make sure that you guys understand. Like, this will float back and forth, and it won't stay the same all the time. And so actually, I'm gonna switch to a pencil so that we can erase as needed. So if AB is equal to 25 and DC is equal to 13, how do we know the measurement of EF? Well, we add 13 plus 25 and divide by 2. And so we get 19. Because 13 plus 25 is 38. 38 divided by 2 is 19. You should also notice a pattern. 13 and 19 is plus 6. 19 and 25 is plus 6. And so that's another way to check and make sure you've got the right median. Alright, so let's erase. If AE is equal to 11 and FB is equal to 8, well, what's that going to help us solve? Well, that's only going to really help us solve for ED and CF. If AE is 11, how long does ED have to be? ED also has to be 11. If BF is 8, how long does FC have to be? Well, it also has to be 8, because remember, F and E are the midpoints. But the question says, what's the length of AD? Well, that's just segment addition. AD is 22. What's the length of BC? Well, BC is 16. Huh? All right. Where this gets hard is where we have to work backwards. So, for example, if AB is 29 and EF is 24, great. I can't add these two things together and divide by 2. That's not going to work. I would end up with a number bigger, and we know this isn't bigger. So we have two ways to do it. You can either do the reverse and notice the pattern, or you can put a variable here. And so then we know that x plus 29 divided by 2 is equal to 24. This looks like the midpoint formula. It's because it is. So how do I undo this? Well, I have to multiply by 2. X plus 29 is equal to 48. And then I subtract 29. And so x is equal to 19. So we did the algebra and got the answer But again, when you have these two numbers, you can follow the pattern rule. Again, it's up to you. Either way, you either use the midpoint formula and do the reverse, or you follow the pattern. Where you have to use algebra is when they do this to you. Now I'm going to redraw this picture down here for this one. When they tell you that AB is equal to 7y plus 6, DC is equal to y minus 5, and EF is equal to 5y minus 3. Well, what is the first thing that we have to do? We have to add the top and the bottom, 8y plus 1. But remember, what did we do with the top and the bottom in order to solve it? Well, we divided it by 2. And that's equal to 5y minus 3. What's the easiest decision here to make? Is 8y plus 1 easy to divide by 2? No, because we're going to end up with a fraction and we don't want that. So it's easier to multiply by 2 to get rid of this. So 8y plus 1 is equal to, I'm going to multiply this side by 2, 10y minus 6. Okay? And so I take this over here, I take this over here, 7, 2y, y is equal to 3.5. Okay? Now, we still ended up with a decimal, but that's okay. And actually, I gotta double check my answer on that. So, figured out the error. It's supposed to be y plus 5. So 8y plus 11 is supposed to be y plus 5. My bad, guys. So 8y plus 11 is equal to 5, divided by 2 is equal to 5y minus 3. And so then 8y plus 11 is equal to 10y minus 6. This is 17 is equal to 2y. And so this is y is equal to 8.5. And so then when we check it, our answer's in here. 8.5 plus 5 gives me 13.5. 5 times 8.5 minus 3. Gives me 39.5. And then 7 times 8.5 plus 6 gives me 65.5. And again, that matches our pattern of a difference of 26 from here to here and 26 from there to there. Again, I'm really sorry about the mess up on the problem. I'll take care of that for future problems. This is supposed to be y plus 5. So again, you add these two together, you multiply the middle and set them equal to each other. So 8y plus 11 is equal to 10y minus 6. And then you go from there, and you can substitute it back in. So on the workbook, you're going to do problems 11 through 16. And again, remember, you add the top and the bottom, and you double the middle, and set those two things equal to each other. If you just have the top and the bottom, then you just add them together and divide by 2, and that's going to help you find the middle. So again, certainly do 11 through 16, and you can come check with me. The other thing we want to talk about is to be able to review a theorem from before, okay? And so you can tell here we have the triangle, but also in the triangle I have I have a trapezoid here made by cutting the triangle. And so if I have a trapezoid that's inside of a triangle, the segment that joins the midpoints of two sides of a triangle is proportional to the third side And it depends, but it'll have a fraction as long as the third side. So I think it's half in this case. So for example, if this is 4 and this is 4 and this is 4, then we can do obviously if this is the midpoint, then both of these have to be 4. So if 4 relates to 4 and 4 relates to 4, then 4 also goes over here and we get a total of 8. And we've talked about that in the past. And so, as this builds up, if this is 4 all the way down and this is 6 all the way down, then we can certainly find a ratio if this is 5. So then this would be 10 and this would be 15. And so, we've talked about that as we've gone on throughout. Obviously there's 3 triangles here. So 4 over 8, 5 over 10, 4 over 12, 5 over 15. So, we talked about looking at all 3 triangles that exist. Even if they're not equilateral. And so we've talked about that. And so that's just a real quick review of something that we already know. All right. The final thing that I had you doing for this particular part of the notes on trapezoids was being able to look at kites and apply what you know to solve for missing figures. Now, obviously, we look at these trapezoids, and one of the things that we talked about is in a quadrilateral, all the degrees have to equal 360. And so, if this is 101 and this is 48, then obviously these equal 149 degrees. And so, in a triangle or in a 4-sided figure, they all have to equal 360. So we have 211 left, which means this one and 2 are both going to be 105.5. Okay. And you can go apply those rules to all of that. The other thing I will tell you is, you notice these 2 lines cross. Any angle that's in the diagonals will equal 90 degrees. And so you can use triangle rules to help you as well. So go ahead and finish questions 20 through 30 on the kites. Hopefully, like I said, you'll be able to use some old rules to help you out with that. Any questions, I'll definitely be around to give you assistance, and we'll go from there.